Sliding through slopes. The big idea. When construction workers and designers create public facilities, including stairs and slides for playgrounds, they must consider certain guidelines to maintain safety. The guidelines for stairs must fit a 0.45 to 0.65 ratio or slope, and slides must have no more than a 0.577 slope, or a 30-degree angle. The challenge. Students will design and build a model slide based proportionally on playground slides with a slope ratio not to exceed the safety guidelines of 0.577. The essential question: does the slope and steepness of a slide impact the slide's velocity? The criteria for this challenge was put into 5 components. A slide model that is as close to a slope of 0.577 and it cannot exceed due to safety laws. Students had to make a proportional scale model of a slide from the playground slide to produce a maximum slide length needed using a scale factor of 1/2. A slide that will produce the fastest velocity possible using the right materials to prohibit friction. An equation for the slide that compares ground to height to visually represent the slide including starting height. The students also used a Cabbage Patch doll to calculate the velocity of the slide. Prior to the challenge, I took the students over to the local playground. They were able to measure the rise and the run and calculate the ratio of the steepness of an actual playground slide. Some questions to guide students along on this challenge are: when measuring steepness, what are the variables being looked at here? Rise to run ratio? When examining slope, are there different forms or representations of slope? Does slope determine speed? Does force come into effect when considering speed? Does friction affect velocity? In the first activity, Safe Stairs, students will measure the rise and the run of stairs in the school building and determine if they are deemed safe. Students will relate stairs to slope triangles and make connections to proportional slopes. In Activity 2, we call it the roller coaster velocity activity. Students will discover that the initial value, which is the height of a roller coaster, will determine the velocity of an object. Students will use foam pipe insulation to construct a coaster track that contains a loop. They will then use a marble to test if the slope is steep enough to make the marble loop the loop. Students were instructed and guided on how to use the engineering design process. First, the students were able to brainstorm slide ideas and materials that they were going to be given. Then they took measurements and calculations of a real playground slide. Students then designed and built a proportional slide prototype. After that, they tested the slide to determine the velocity. Finally, they refined their design with different surface materials.